Yeah, so once again, good afternoon everyone, and welcome to the today's webinar on performance of pneumatic system in Automation Studio. Okay, so earlier webinar there was it was on hydraulic simulation. Okay, so if you have any questions related to the hydraulic simulation, so you can type the questions in the question pane. Okay, so if you have any questions during the webinar, you can type it in the chat box or the question pane. Okay, so I will take the questions during the webinar or at the end of the session. So in this webinar, we will focus on basic pneumatic circuit design, right? As we have invited many of our customers from different countries like Indonesia, Malaysia, Philippines, Vietnam. Okay, so looking at the customer's requirement, we are focusing on the basics of the technologies here in this webinar series. So I will start with the basic pneumatic circuit. I will show a circuit of sequencing. Okay. Then we will see the electro-pneumatics part using Siemens PLC. Then illustrate library we will see. I will show you an example of technical training material tab. And then we will see some industrial application. And again, at the end, we will see the Q&A part. Okay. But before moving to the actual demonstration of the software, I would like to talk about our company, what we do and what our products are. Okay. Okay, just a second. Okay, so we are a team of 150 engineers and software specialists. We are ISO certified company. We were founded in 1986. We are leading the industry by designing world-class trade-oriented tools in the fields of fluid power, electrical engineering, industrial automation, and custom software development. So we have three offices. Our headquarters is at Montreal, Canada. We have two branches. One is in Mannheim, Germany. Other is in Pune, India. Okay. Then we have in-house expertise. So we have in-house expertise in the fields of like softwares. We have software specialists working in software engineering, database design and support, network support, multimedia applications. We have engineers working in pneumatic systems, hydraulic systems, mathematical modeling, electrical systems, automation engineering, robotics. Then we have industrial automation also. We work in PLC programming, SCADA, HMI, that is human machine interface, electrical controls, process simulation, and robotics. So these are our products. We have Automation Studio Professional Edition to create, analyze, troubleshoot, and validate multi-technology circuits. Okay, which is for industry professionals. Then we have Automation Studio Educational Edition to train future technicians and engineers on hydraulic, pneumatic, and various technologies. Okay, so this is specifically for technical institutes like ITI colleges, engineering colleges, vocational centers, polytechnic colleges. Okay, and then we have Lime Manifold, which is a complete hydraulic manifold software solution for design, coding, and prototyping. And we have a separate software, which is IoT-based software called Anden Studio, which is a complete solution to optimize your production, or you can say it is more related to production planning or Industry 4.0. So these are our objectives. We have a long-term relationship um, with the customers, and we also provide effective support by phone, email, or online. We also provide dedicated representative for each account, and we also provide support materials like training videos, demonstration files, quick start guides, etc. So these are some of our milestones. As we started in 1986, we were then known as HydroSim and NeoSim, which was the DOS version of our software. Later on in 1996, we started with Windows-based version, that was Automation Studio 1.0. From then till now, as per the customer's feedback and their requirement, we are evolving ourselves, and currently we are working on Automation Studio 9.0 SR3, Service Release 3, and the third version of Andon Studio. Okay. So what is exactly Automation Studio software? It is a multi-technology software which deals in various fields like simulation, animation, trade-oriented system design, and machine documentation. You can draw your circuit using hydraulics, pneumatics, manifold blocks, some part of mechanical, electrical systems like electrical control, electrotechnical one line. Then we have separate library for digital electronics, instrumentation, process control, robotics. You can draw circuit using various PLC ladder logics like Allen Bradley, Siemens, IC standard, Mitsubishi. You can draw the circuit using block diagram. Then you can link the Automation Studio circuit with the trainer kit using Canvas, OPC client servers, then SFC, sequential function chart. We have some extraordinary features like workflow manager, FMEA, Teachware, manufacturer's catalog, bill of material and reports, component sizing, energy consumption. Okay, and fits for multiple program, as you can see here, a list of programs. Okay, okay. So our software fits for all these programs. So what are the key benefits of like Automation Studio with respect to student, teachers, and school? For student, it validate theory studied in class. So whatever a student is learning in his or her textbook, okay, they can validate that circuits in our software dynamically in full color, right? So with the help of this software, they can interact, okay, they can interact with the circuits, right, in our software. They can create the simulation, they can measure the properties across that circuit. Also for the teachers, they can facilitate demonstration of system interaction. Okay, so with the help of this software, they can make these sessions interactive. They can enhance teaching and learning by working on a virtual system. No need to purchase a single technology software. As this is a multi-technology software, you can use the software in conjunction with other departments also. Okay, so schools can also provide e-learning or remote access to students. Okay, and they can monitor the students at home. For example, you want to give any project work or homework at home, so you can provide the access of software to students, and you can monitor them with the help of license manager. Okay, so that is also possible. We have an international presence. We are available in 13 languages, and we have sold our software in more than 150 countries. Okay, so our software is used in high school, career centers, colleges, universities, workforce development. We also provide technical publications in Automation Studio. For example, you can see this circuit. This circuit is from this book, this textbook, that is Fluid Power with Application by Anthony Esposito. Similarly, there are many other applications or the circuits available in Automation Studio from different publications. So you have to just go to Technical Training Material tab, click on the exercise which he or she wants to work on. Okay. Again, we provide some interactive exercises in this way. You can create your own exercise also, right? These exercises which you are seeing here are built-in interactive exercises which are easily customizable, right? So we also call it as Teachware, right? I will also show you an example, live example. You can also create digital twin of your own equipment. So earlier during the presentation only, I've told you that you can link Automation Studio circuit with the trainer kit. So you might be using such kind of trainer kit in your labs. Okay, for example, you are using a electro-hydraulic trainer kit, right? So you can just create such kind of circuit in your Automation Studio, and you can link it with the OPC server client, right? So in this way, you can create the digital twin of your own hardware kit. Okay. You will also find illustrated libraries in Automation Studio. So we have libraries for PLCs, hydraulics, AC/DC motor control, pneumatics. Okay, there are some more libraries which are available in the illustrated libraries. Okay, here in this slide you will understand the three ways to create, simulate, and troubleshoot in Automation Studio. You can draw the circuit using ISO symbols. You can draw the circuit using illustrated components. You can draw the circuit using virtual trainer kits. Okay, so here you will find the simulation of actual virtual trainer kit and the hardware kit. So on the left hand side, you will find the actual pneumatic trainer kit, wherein that person is connecting the pneumatic components. Okay, he is completing that circuit. And on the right hand side, you will find a pneumatic virtual trainer kit, where you will find we have designed the same component which you are seeing on the left hand side in our software, and we are connecting that using the curved link, okay, which is available in our software, right? So in this way you can use the like illustrated components. Now what are the benefits of virtual plus hands-on experience? If you are using only trainer hardware kit or trainer kit, you can say, so only like 2 students per unit can work on them. Okay, there are multiple limitations you can see, and it will be an expensive option also. But if you are using hardware kit with software, right, so it will be affordable option. So you can see there are multiple benefits available here. Yeah, yeah. Again, one of the most important feature of Automation Studio is the manufacturer's catalog. So we have pre-configured manufacturer specific components available in manufacturer's catalog, available from all these manufacturers. So students or teachers, even teachers, can just drag and drop the product whichever they want to use, and they can build an industrial compliant circuit. Okay, even students can learn about the um, their like product behavior or the product configuration, how they are done. They can learn about the specifications also. Okay, so I feel that this is a very important thing that they should learn about the industrial like products. Okay, so this is the partial list of our industrial clients. So we have clients like Airbus, NASA, John Deere, Kubota, Caterpillar, Hitachi, L&T, China Steel, US Steel, Epiroc, Komatsu, Honda, RV Hightech, Skyjack, Terex. Okay, yeah. Okay, so this was about our company profile. So if you have any questions till now, you can just drop the questions in the question pen. Okay. Yeah. So let me move to the software part. Okay. Okay. I assume that there is no question till now. Now moving to the demonstration of the software. So the interface which you are seeing now is the interface of Automation Studio Educational Edition 9.0 SR3 version. Okay, this is the latest one. Okay, and like this is the premium one where you will find all the technologies. For your information, that our software is totally customizable as per the customer's requirement. If you are saying that you want to go for only hydraulics and pneumatics, you can definitely go for hydraulics and pneumatics only, right? So it is totally uh, customizable as per your requirement. Now on the left hand side, you will find the library explorer, where you will find all the technologies or the modules, you can say, like hydraulics, proportional hydraulic, pneumatics, proportional pneumatic, drive and transmission element, environment and control, instrumentation and process control diagram, electrical control, GIC and IC standard, then digital electronics we have, We have this type of like ladder diagrams like Allen Bradley, IC standard, Siemens, LS Electric, Mitsubishi, Electrotechnical, IC and NEMA standard, Electrotechnical one line, blocks, HMI and control panel, and then robotics. Okay. So today we are going to look into the pneumatics part. So here again, I want to tell you that this is the generic library. This is not the manufacturer specific library. Here, if when you expand this library, you will find all the components associated with that technology. Okay, right. So you can explore all these technologies. Okay. On the right hand side is the project explorer. So whichever the project you are working on, you will find here. The top bar is your ribbon bar where you will find the tabs like home tab, edit tab, view, simulation, system analysis, fluid, tools tab. Again, student tab is also available, wherein we have compiled all the features of the other tabs in a single tab, and we have named it as student tab. Okay, so these are like basic features and functions like which is required for the students to use, right? So like student can just go to this tab and start using the whatever the features or the functions they want to use. Now again there is like support and the technical training material tab. So we will look these tabs in brief during our presentation. Okay. Yeah. So let me draw a basic hydraulic circuit first. Okay. So this is center. The center part is a workspace. If you go to edit tab, sorry, the view tab, here you can see a display option where you can use the grid view also. So if you are feeling like you cannot draw the circuit properly, you can use this grid view. I will take drag and drop this pneumatic pressure source. Here again you can find the standards of the component like 1991, 2012, no standard. Okay, so I will take a pneumatic pressure source. Take this in this way, right? Then I need a double acting cylinder here. So you can take a double acting cylinder in this way. Okay, I'm taking this. And then I will take a variable throttle valve I will take. Okay, so now I'm drawing a basic pneumatic circuit only. Okay, and okay, so you can take this, and I can also take a copy of this product in this way. Okay, okay, so here we can just take this, and then I want a pressure regulator also, so I will take a pressure regulator here in this way. I will take a directional valve and filter from the library. So I have already opened this library. So I will go to directional valve, and here you will find all the types of directional valves. If you want to choose 2 by 2, 3 by 2, 4 by 2, 5 by 2, 5 by 3. So any of the directional valve you can choose it as per your requirement. Okay, so for now I require 5 by 2. Okay, take a 5 by 2. Okay, so here I've taken a 5 by 2 directional valve, and then I will take a manual run filter. So that filter I will find it in the fluid conditioning tab. So here you will go to fluid conditioning folder and go to filters here, and I will take a manual filter. Okay, and now I will connect it. Okay, connect in this way. So it is very easy to connect the circuit. The lines which you are seeing are not just the CAD lines, those are actual pipes and hoses, and they are having their own properties, and you can edit the properties, right? And here I need to connect to exhaust. Okay, so I will connect to exhaust here. Okay, so you can see this is my basic pneumatic circuit. Okay, so here again, like how to edit the properties. When you just double click on any of the component, for example, I have double click on this cylinder, you can see, you can find the all like data properties of that component. So right from the equations, okay, how the modeling is done, the modeling parameters, characteristics with respect to unit, external data. Okay, so all of these data properties you can edit it here. Similarly, if you have some configuration properties, like you can edit this with the help of curves also, like driving force curve, resistive force curve, you can edit it. If you want to do modifications in the symbol of the component, like you want to add the spring here, you can add it. If you want to do modifications in the piston, cushion, okay, cushion also you want to, so you can edit that component symbol and then you can use it. Okay. Similarly, for the directional valve also, you can see, you can edit the data here. If you go to technical specifications, if you want to make changes in the symbol, like design of the symbol, that also you can do. Here you can make the valve to on off proportional. You can edit the number of ports, number of position, initial position. Here you can select the command, different types of commands. Okay, like external pneumatic pilot, push button, roller, lever, any of the like command you can select. Even the standard type of spools, if you want to select the standard type of spools, you can select from here. Okay, for example, I want to select a spring here, so you can add the spring here. Okay, and I will say okay here. If you want to edit the area flow curve, you can edit it from here. Pressure drop curve, if you want to edit it, you can edit from here. If you want to add the leakages, you can add the leakage here. Okay, okay, yeah, so that is very much possible. Okay, now what I will do, I will highlight the component here. Go to document properties, I will highlight the component, so it will give you a good visualization of this particular circuit, right? So quickly I will just start the simulation, and you can see there is like uh, different colors in the component and different color in the line. So these color settings can also be done in the software. Okay, so here you can just go for the simulation. Okay, and again you can see, okay, here in the circuit also you can do the air installation. So if you want to do, okay, so you can also change the clogging level of the filter. You can change the setting pressure of the pressure regulator. You can change the internal diameter or the cracking pressure of the variable throttle valve. If you want to add the external load at some inclination, you can do it. Okay, you can do it from here. Okay, and again during the simulation, if you want to measure any property, you can measure the properties also. So you can go to simulation tab here, and then you can like use this dynamic measuring instruments to measure the properties across the circuit. For example, I have component dynamic measuring instrument. If you want to measure any property at any component, okay, for example, I'm selecting this cylinder, right, and I'm dragging and dropping this measuring instrument here. Okay, so you can select any of the property from here. So all these properties are related to this cylinder only. Okay, for example, I want to select like for example, linear speed, and you can display the unit and precision level. You can add the comments also, you can record the value also. Okay, and if I want to measure the flow of this pipe also, you can measure flow speed. Okay, so you can measure it. Similarly, we have node dynamic measuring instrument. If you want to measure any property at any nodes, okay, for example, this node, I want to measure the input pressure at this particular node, but you can measure like density and temperature also. Okay, If you want to measure the output pressure also, you can measure it. Okay. Similarly, we have differential dynamic measuring instrument. If you want to measure the differential pressure at two nodes, so you can measure the differential pressure also. And when you start the simulation, you can see how these properties are being measured. Okay, you will get the live measurements, okay, during the simulation, so you can measure in this way. Okay, so if anybody has any question, you can drop the question in the question pane. Okay, now again, you have measured the properties during the simulation, but if you want to analyze the circuit, right? If I want to analyze the circuit using a graphical way, so how you can use those graphs in the software? So in order to use the graphs, we have plotters here. So we have y of t plotter, y of x plotter, and z of xy plotter. Okay, so you can take y of t plotter here. Now, again, how to use this plotter? So you can drag and drop this component also in this plotter. So you can measure any of the property, and you can see a scale is generated automatically. Similarly, you can drag and drop this measuring instrument also. This measuring instrument is measuring pressure at this particular node. Okay, so you can use this. Okay, so and also you can measure the flow also. Okay, measure the flow also. Okay, so you can use this. So here you can see when I'm starting the simulation, you can see how the graph is being plotted. So in this way, you can use the plotter to plot the graph. Okay. Here in the plotter also, you can adjust the scale. You can adjust the scale with respect to different axes. Okay, in this way, you can add the cursor also when you are adding the cursor. Okay, when you are adding the cursor, you can just get the values at the particular curves. You can add multiple cursors like this, and when you are adding multiple cursors, you will find a differential value between the 2 points again. If you want to label any point, you can add the annotation. Okay, you can edit that annotation also. If you want to, if there are multiple properties in your plotter, you can always display these legends. Whenever you display the legends, you can see the curves will be highlighted. You can print the plotter image. You can copy the plotter image either in the Word file, Excel file, even in your workspace in this way. Okay, like this. Okay, so in this way, you can just plot the or copy the image. Even you can export the value in the .txt format. Okay, yeah, yeah. So this was about the like plotter. Now, as I told you earlier, like this is the ISO symbol circuit. This is not the illustrated components. You can draw the circuit using the illustrated components also. So let me show you how to draw the circuit using illustrated components. So let me move this, okay, circuit here. Okay, now here in our software, we have different types of illustrated components which will be found under this library, that is open library. When you click, you will see like different libraries like aeronautic, DC electrical, residential electricity, input output PLC cards, motor control, renewable energy you will find. Okay, then residential electricity, cylinder plus load, you will find hydraulic illustrated components, sectional components. Okay, then PID components, illustrated one line, PLCs you will find. Okay, then illustrated pneumatics, sectional components also. Okay, so here you can draw the take the components, any of the component like sectional you can take. You can take this Electro components also. Okay, so let me take the pneumatic sectional components here, and so I will take a compressor as a pneumatic source. You can take a like a lubricator and then a regulator, right? So you can take this here. So let me take this here. Okay, and then I will take a directional valve. So I need to take 5 by 2 way valve. Okay, so we will take a 5 by 2 way valve here. Okay, and then I will take a, okay, let me take this one. Okay, and then what I will do, I will take the variable throttle valve also, which comes under the flow control valve. Okay, so you can take the, okay, this one, and same here I will take. Okay, okay, so I've taken the variable throttle valve, and then I will take the double acting cylinder also. So you can go to actuators and you can take this cylinder. Okay, so now I will connect this circuit. Here in the ISO symbol circuit, you might have observed that I have connected this circuit using the straight lines, but here I will connect it using the curved link. So you will find this curved link here, and I will connect this. So here you can adjust this lines also, the curved link. This I will connect it here. And you can also change the line function like pilot, exhaust, pressure. Okay. So you can take in this way. Okay, so you can just connect this circuit using the flexible link. Here in the flexible links, you can also add the node and subtract the node. Okay. Now I would like to take to exhaust here. Okay, so you can go to flow lines and connection. You can take the direct exhaust. Okay, so this is my pneumatic circuit which I have drawn here, right? And what I will do now, what I will do, I will connect both the circuit to PLC circuit. Okay. Okay, so I will take a PLC here. So I will take PLC cards from the electro control library. Okay, and I will use these PLC cards. So you can also design your own PLC in our software. So here the size is not like okay, there is not much size. Okay, so I can just increase the size here, page size. Okay, and I will take a Siemens ladder, right? So let me connect this here, make the connections here. I will take a 24 volt here. Okay, let me zoom it. I will connect a common here, again a common here. Okay, and I will take a push button here. I will connect to input 0. Again, I will take one, connect in this way. Okay, so I will connect it to S1, and here I will connect to S2. Okay, so you can just connect it. Okay, so you might have noticed that it is very easy to make circuits in Automation Studio. Our software is very user friendly. Okay, and now you can see this PLC cards are ready. Now I have to make the connections here in this ladder. Okay, so I will take the normally open contact here in this Siemens, okay, PLC ladder logic. Okay, so I will take the close contact, then I will take output coil. Okay, same I will repeat it here. Okay, and now I will complete the connection. Okay, so so all the contacts I have taken, required contacts. Now we have to link this ladder to the PLC card. I can just double click it here and we can move it upwards. Okay, so you can see this push buttons are input 0 and input 2. So I will link it to input 0 and input 2. Okay, so I will link it to in 0 and 2. I will search it here. Okay, so you can see these are linked. These are getting linked to these contact coils. For the output, these outputs are linked to output 0 and output 4. So I will link it to out 0 first. And this one I will link it to output 4. Similarly, this inputs input 2 in 0. Okay, so in this way, like you can link the PLC ladder to the input and output coil. Okay, PLC cards. So now we have to link this PLC, the whole of the PLC to these two circuits. So how you can connect it? So you will have to just double click on the directional valve. Okay. S2. Okay. So we will zoom all the components and now we can start the simulation. So you can see how the simulation is working. So in this way you can connect the PLC to the pneumatic circuit. Okay. So you can connect the Siemens PLC or any other PLC. Okay. here. Okay. Yeah. So if you have any question, you can drop the question in the question pen, right? Okay. Now you can also use the illustrate PLCs here. So we have different types of illustrate PLCs. If I open this library, so here you will find like PLCs of Allen Bradley. Okay. You will find like Rexroth PLCs also, Eaton, then Koyo we have, okay, LS Electric, Mitsubishi, okay, many of them use Mitsubishi, okay, okay, Omron Schneider you have, Siemens you can see. So all these PLCs you can use it for the simulation, okay, yeah. Also I wanted to explain, yeah, one more thing, yeah, you can also change the language as we have many languages available. So we have English, French, okay, Portuguese, Italian, we have Chinese, Japanese, okay, Vietnamese language we have, okay. So you can use these languages here, okay. Okay. So you can use this. Okay, now this was about like the basic pneumatics using the Siemens PLC. Let me show one example sequencing of pneumatic circuit. Okay, sequencing, right? Simple example. So what I will do, again, I will take a like pneumatic source here. I will take a I will go to I will get a like conditioning unit, and that is the FRL unit. Okay, I will connect this here. Also, I will take the grid view. Okay, I will take a 2 by 2 way valve. I will take a 2 by 2 way valve here. Okay, and then I will take 3 by 2 way valve. Okay, 3 by 2 way valve I will take. Okay, and I will take again 5 by 2 way valve, and that I will take of like pilot operated valve. Okay, so I will take a 5 by 2 way valve. Here again I will take a 3 by 2 way valve, but I will take a roller operated valve. I will rotate this and connect it here. You can take this here. Okay, and then I will take the actuators. So I will go to actuators and I will take a single acting cylinder. Okay, so you can take a single acting cylinder here. Connect it. Okay, and again I will take a double acting cylinder. So you can take a double acting cylinder here. Okay, yeah, and I will zoom all the components. And now I will complete the circuit in this way. You can see, you can connect the circuit here. Okay, so this will be the pilot line. So okay, you can see the pilot line. As soon as I have changed it to pilot, The line function has also changed. You can see the dotted line there. Okay, now I have to connect the exhaust. So you can take it in this way. Okay. So now, okay, so I will highlight the components here, and now what I will do, yeah, I will start the simulation. Okay, so again, as I told you, like you can set the pressure here. Okay, so let me change here the arrow. So I will go to technical specification and I will want this arrow. Okay. So you can say I can activate this. Okay. So why it is not moving? Because this is not linked here. So I need to move this here and move this cylinder here. Okay. And this cylinder, okay, this roller, I can link it to this roller. So you can associate this. The cylinder, so you can find the name of the cylinder here. So P8A2. So let me check this simulation. Okay, let me move this. Okay, so you have to align this. Okay, so so you can see how this simulation is working. So in this way, you can just create the sequencing of the circuit, okay, with the using with the help of like a roller operated valve, right? Right. So if you have any question, you can just type the question in the question pane. Okay. Yeah. Okay. So moving to the next part, the virtual trainer kit. So we have various virtual trainer kit templates available in the software, like right from electrical, hydraulic, and pneumatic, and other technologies. In the last webinar, you might have seen the hydraulics trainer kit. So here we can see the pneumatics one. Okay. So we have various templates. You can use these templates in order to create the circuit. You can create your own templates also. Okay. So you can use this template here. Like here you can see this is a combination circuit, and you can see the relays are like relay coils are there, push buttons, HMI lights are also available. So now you can make the connection in this way. You can also edit the color of the line, these lines. You can edit this by going to edit tab. You can see the color has also changed, and here I will connect this. So you can make it to another color in this way. Similarly for this, you can delete this. Change the color. You can make the changes here. Similarly, this one also you can. Okay. So when I start the simulation, you can see how this simulation is working, and also you're getting the real-time feedback of your simulation also. Okay. So in this way you can connect this light, you can connect the circuits, and also you can see the sensor how it is working. It is as soon as the like piston is reaching this sensor, the light is also glowing. Okay. So when I click on this push button, you can say, so in this way you can use the virtual trainer kits in our software. Okay. And here you can also try to use the measuring instruments. So you can measure the input pressure. Okay. You can try to measure input and output pressure like this. Okay. Okay. Yeah. So this was about the virtual trainer kits. Now the last part is like the teachwares. So we have various teachwares available. For example, uh, so like for example, this pneumatics you can see. We have like physics. You can use this Boyle's law. Okay, then Charles law, right? So this kind of trainer, like sorry, the teachwares or the technical training material tabs, you can use it. Okay, even you can see this how this the circuits, you can see different circuits are available. Even we have this technical training material tabs, oh sorry, textbook, you can see. Okay, hydraulic circuit, pneumatic circuit, you can use it. Book schematic, you can see. So again, okay, so you can find this type of circuits here in the software. For pneumatics also you will find, you can see such kind of circuits you will find it here, right? Yeah. So this was about the teacher, and let me show you some examples where you can just like you will understand like the capabilities of the software, how complex you can go in the automation studio. Okay, so let me, so let me open a file. Um, okay, just a second. I'm opening the file. So this is one yeah, this is one example of pneumatic brake. You can see how this pneumatic circuit is drawn. Yeah, okay, so in this way you can just create your circuit. Yeah, this is one example of electro-pneumatic conveyor, right? So here you can see this is a combination circuit where you will find 2D animation. Okay, so you can see the 2D circuit which is linked to the pneumatic circuit and then electrotechnical circuits also. On the right hand side, you will find the motor driven circuit, then electronic circuit also you can see for the logics. And again, you can see the PLC here below, right? So you can combine all these circuits to create your industrial component circuit. Okay, yeah. Yeah, so I can see one question of time simulation pace. uh, so let me see. So can you elaborate this, fam, that paces of 5 to 10 milliseconds, right? uh, so you want to see the timer, right? uh, Let me see if I have any example to show you. Okay, you want to see the simulation pace. Okay, okay, okay. Understood, understood. Okay, so here you can go to simulation pace. Okay, you see here in the simulation option, you can see there is like simulation pace 1, pace 2. So you can make it to 0.5 millisecond, 1 millisecond, 2 millisecond, or pace 2. You can see, you can select the settings. You can do the settings as per your requirement. So here what we have done by default, we have set this parameters like simulation slow speed factor at 5, thermal simulation at 1000 millisecond, right? So you can change the settings as per your requirement. Okay, I hope I have answered your question. Any more questions to ask? Okay, so this was the webinar on the pneumatics. In the coming coming this week, we have 2 more webinars on electrotechnical and robotics. Okay, please do register for this webinar. Also invite your colleagues, friends. uh, Even students can join this webinar, professors can join this webinar. If you want personalized demo, you can email me, right? If you have any feedback regarding this webinar, you can email me. Okay, please do let us know how you felt about this webinar. How was your experience? If you want to, if want quotation and demo also, you can email me, right? So please share these invitations with as much as possible with your friends or any other who want to learn about the software or the hydraulics and pneumatics. Okay, yeah. So see you in the further webinars. Thank you very much for giving your time, right? Yeah, thank you very much. Have a good day.